So the first half of lesson 7.5 is going to be talking about the zero product property. And this zero product property is something that is fundamentally already known. So let's start with that. It's something that you already instinctively know is true, but we probably have never formally discussed it in class, at least not this year. And you're going to find that this really basic mathematical concept that you were already aware of is going to really be at the heart of solving polynomial equations. So notice a shift. The stuff that we've done up to now, we've added, subtracted, multiplied, and now divided polynomials, but we actually haven't solved them yet. Right? We haven't solved for what is the x value that makes that true. We haven't done actual polynomial equations. That's what we'll start talking about tomorrow. But in order to get there, and actually a little bit, right? But in order to get there, we are going to talk about the zero product property. It's going to be at the heart of how we do that. So, before we talk about that though, let's just talk about factored form. So yesterday, or the last few days, you've been dividing. You've been taking polynomials that were in that nice, cleaned up standard form, and you've been breaking them down into the smaller binomial or trinomial factors, right, that go into that evenly. So a polynomial, let's start with this definition. A polynomial is in factored form when it is written as a product of factors instead of the simplified standard version. We have a couple of examples here. So we can have, for example, we have this polynomial right here, x squared plus 2x. That's in that cleaned up, nice standard form. And if we were to write that in that factored form, it would be this. That's the separated out version, where it's separated into two polynomial factors that, when multiplied, give you the other one. So when we first started this whole polynomial chapter, we talked about distributing and FOIL and techniques where we could multiply stuff together and get it to look like that. And then over the last couple of days, we've been going in the other direction, and we've been taking stuff that is in standard form and dividing it out back into the separated factors. So the reason why we do that is because this right here, this factored form, is going to be really important when we're solving. Okay? So now let's talk about the zero product property. This is just something that, like I said, fundamentally you already know to be true. So before we even fill in blanks, let's just talk about something. Let's talk about zeros and multiplication. So you already know that at the heart, of all multiplication, or whatever, a basic sort of principle in multiplying is that any time you multiply by a zero, your answer is going to be 0, right? So anytime you multiply by 0, the answer is going to be 0. We all know that to be true. Okay? So that leads us to this concept of, hey, if I have the product of two values, right? Let's say A and B. Let's pretend for just a moment that you and I do not know what those are. But we know that we're multiplying A and B together. And then I tell you, oh, but by the way, when you multiply A and B together, the answer is 0. Then there's a really basic concept that you must know is true. And that is that the only way that A times B can be 0 is if either A is 0 or if B is 0. Because not only do we know that multiplying by 0 gives us a 0, we also know that if I multiply two numbers and neither of them are 0, then I'll never get a 0, right? So, yes, multiplying by 0 gives us 0, but more importantly, if I take two numbers that are not 0, I'll never be able to multiply them and have 0 be the answer. So if 0 is the answer, like we have here, that must mean that one of those two numbers is a 0. Okay? Like I said, a real basic concept of multiplication and math that you already know is true, but this right here is going to be at the heart of solving polynomials. Okay? So, when one side, let's kind of fill in our vocabulary here and see, how we're really going to tackle this today. It says when one side of an equation is a polynomial in factored form, and the other side is 0, So that basically means coming back here, like if one side is already written like this, and the other side of the equation is equal to 0, then the solutions of the polynomial equation are the values for x that make that equation true. So actually, I might have skipped something. I started from the beginning. So when one side of the equation of polynomial is factored form, and the other side is 0, there you go. We can use the zero product property. I jumped to the other line. We can use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are the values of x that make the equation true. And the solutions of a polynomial equation are also often called the roots. So when I say find the solutions, it's the same thing as saying find the roots. Or sometimes we also call it the zeros, because we're going to be setting it equal to 0 so much. Okay? And when two or more roots of an equation are the same number, we tend to say that that equation has repeated roots. Remember, if I write it, you write it. Okay? All right. So what on earth are you talking about, Mr. Della? Well, let me tell you. This is the idea. Okay? So if I can take a polynomial, that's the first part, ensure that it is written in standard form, and it's set equal to 0, then the only way, and again, here's the zero product property, the only way that 2x, that factor, times x minus 4, which is our other factor, the only way that those two things can multiply together and result in a 0 is if either that guy is equal to 0 or that factor is equal to 0, right? That's the only way. The only way that we can multiply two things together and get a 0 result is if one of those is 0. So if 2x is 0, that would make that equation true. So we solve that guy. Well, I would just divide by 2, 0 divided by 2 is still 0, so that's one of our solutions. The other option is that the other factor, the x minus 4, is a 0. So then we solve that for 0, we add 4 on both sides. Turns out that if x equals 4, then that makes this equation true. Okay, so the roots, or the solutions, or the zeros, those are all synonymous, are at x equals 0 and x equals 4. This has two solutions. Okay, and either one of those, if you plug them back in, and you tested it, you would realize it would make that equation true. If I plug in an x equals 0 and I work that problem out, it'll work. If I plug in a 4, it's also going to work. Okay? Same thing with part B here. You have a polynomial in factored form equal to 0. That's always going to be our goal. And then I can use the zero product property, because the only way that those two things multiply could possibly give us a 0 is if either the first factor, the x minus 3, is equal to 0, or if the other factor, the x minus 9, is equal to 0. And then you solve, you basically set up two, or as many as you need, right, little mini equations, and solve each mini equation individually. So then it becomes just this little mini one-step equation, add 3 on both sides. Turns out one solution is x equals 3. For this one, we have this other little mini equation, x minus 9 being 0, we'll add 9 on both sides, and then it turns out that the other solution is x equals 9. Like I said, you could plug it in and test it. Like, let's say I want to test a 9. So let's take this original just real quick. If I take this and I plug in a 9 for x, so that means plug in a 9 here and here, because there's two x's here. Well, 9 minus 3 is 6, so this gives me a 6. But 9 minus 9 over here is 0. And 6 times 0 is indeed 0, so that makes my equation true. So that is one of the solutions. Okay? So that's really how we solve polynomials. We break them down into factors that are equal to 0, and then we figure out what would make the zero product property true here. So let's practice a few together on the back page. So let's say I have number 1. That's in factored form, so it's x times the x plus 5. So I've got two factors, two things being multiplied, okay? And it's already equal to 0. That's important to check. So if this times that is equal to 0, the only way that can be true is if either this first factor is a 0 or if this factor is a 0. So you kind of set up two little mini equations, and then you solve each one. Okay, well, the first one's pretty easy because x equals 0 is already kind of solved for me. So that's one answer. And then for the other one, I'm going to subtract the 5 and get at x by itself. So 0 minus 5 is just -5. So these are the solutions, or in other words, the roots, the zeros of my function. Okay, let's try another one. I'm going to skip over to number 3. The answer key will be on Schoology, so you can always check the other ones if you try some other ones. But let's try number 3. I've got 5p, so I've got this monomial right here being multiplied by that binomial. And when they're multiplied together, it's equal to 0. So the only way that can be true is if one of those is equal to 0. So the only way this can be 0 is if 5p is equal to 0, or if p minus 2 is equal to 0. And again, we just basically set up these two little mini equations, and we solve each one. So here I would just divide by 5, but 0 divided by 5 is still going to be 0, so that's one answer. Over here, I'll have to add 2 on both sides to isolate the p. 0 plus 2 is just 2. So these are the two solutions that work in that polynomial, that are the solutions to that polynomial. All right, let's try another one. Let's try number 4. So if we try number 4, again, just check to make sure that the left side or the polynomial side is factored and that it's equal to 0. And if so, I apply the zero product property. The only way that this binomial times that binomial could possibly equal 0 is if either this binomial, c minus 2, is a 0, or if this guy is a 0. Those are the two only possibilities that would make this equation true. And then you just solve each little mini equation separately. So we'll add 2 on both sides. So c equals 0 plus 2 is just 2. So that's one answer right there. Let me erase that so it doesn't look like a 3. And then here I'll subtract 1 on both sides to cancel that. So c will equal 0 minus 1, which is just -1. So there are the solutions. So I think y'all are starting to see how this game is played. Let's step it up a notch with number 5. So on number 5, they're just slightly more, complicated little binomials, but it's still the same idea. Is the left side the polynomial side factor? Yes. It's the product of two things. Is it right equal to 0? Yes. Then the only way this times this can equal 0 is if either 2b minus 6 is a 0, or if 3b plus 18 is a 0. And then you just solve each little mini equation individually. So here, solving a two-step equation now. I make sure that I add or do the opposite of the addition or subtraction first. So that gives me a 6. And then in the second step, we get rid of the division or multiplication with the inverse of that. So b equals 3 is one of my solutions on number 5. Let's do the other side. First, we'll move the 18. Do the opposite sign there. That leaves me with 3b equals a -18. Then in the second step, we'll do the division. So if this is ringing a bell from the fall, that is correct. Solving equations, two-step, multi-step equations is back in business here. It's been a while. And then -18 divided by 3 is a -6. So this would be the two possible solutions that would make our polynomial equation true. All right, let's get down just a little bit. Again, you can just try any of these other ones and test and then check them against the answer key that's going to be posted. Look at number 7. So notice one of the things that's different about a 7 is that there is an exponent. And, don't let that kind of, freak you out. That just basically means I have 2 of those, right? I have 2 of those w plus 4s. We've played with this now a few times when we were multiplying, so we know that I'm not going to just distribute that at all. I'm not going to just do, w squared, 4 squared. No, it really, though, means that I have 2 of these factors multiplied times each other. So it's a w plus 4 times another w plus 4, and then there's also this w plus 1, and then we have a 0. So in this particular one, we actually have 3 factors that are equaling 0. I have to consider the possibility that any one of those 3, since they all have variables, that any one of those 3 could make this true. So I'm going to test each one. Now, it does happen that 2 of these are the same, so you're going to see what happens here. So when I said the first one, if I could say, hey, this times this times this, right? this guy times that guy equals 0. Oh, the only way that's going to be true is if one of those is equal to 0. So I'm going to do W plus 4. So one option is that this first factor is a 0. Another option is that the middle one is a 0. And another option is that this very last one might be a 0. And then we solve each one, right? Well, here I'm going to subtract 4, and one possibility is a negative 4. And then you're going to notice, oh, wait a minute, but this is exactly the same thing. If I bother actually doing the work, I'm going to notice it was the same binomial, so it's the same solution. Another negative 4. This is what I was talking about at the very beginning where I said sometimes you have a repeated root, right? So if you went back to the front page, we talked about, oh, there, right, that very last sentence said when two or more roots of an equation are the same number, the equation has repeated roots, right here. That's what I was talking about. So this is considered to have a repeated root. That's going to have some interesting things happen when we graph, but we're not graphing these yet. So it's not a huge deal at this time, but keep a note on that because it will come up later. All right, and then minus 1 for the last one. So that the last root is a negative 1. So really, our answer here would be my roots are negative 4 and negative 1. And I would say, hey, this guy right here is a repeated root, meaning I have two of those. Okay, so it repeats. Okay. So hopefully you feel pretty comfortable with that. Let's try number 9, and we'll finish off with that one as far as just the regular practice, and then we'll try a couple word problems. So on number 9, same thing, right? Is my left side is factored, and it is. It is written as just the product of factors, right? Things being multiplied. And the right side is 0, we're good to go. So the only way this times this times this can be 0 is if either 4 minus m is 0, or if 8 plus 2/3 m is 0, or if negative 2 minus 3m is 0, right? So there's 3 different options here, and we just need to solve each one. These are all different, though, so I don't think we'll have repeated roots, but we'll find out when we solve it, okay? All right, so let's start with this one. Let's move that 4 out of the way. So if I cancel the 4, that leaves me with a negative m is equal to a negative 4, and I don't want that negative, so I'll multiply everybody by a negative to switch the sign, and there's my first solution, a possible, yeah, my first solution. It's a possibility here. Let's try the next one. On this one, we'll move the 8 out of the way. Minus 8, that cancels. So now we've got 2/3 m is equal to negative 8. And then remember, we'll review here, it's been a while, but when we're multiplying by a fraction and I want to eliminate it, the best way to do that is multiply by the reciprocal, right? So I'm going to multiply both sides by the reciprocal, and that's going to cancel the fraction isolated. On the right, though, if I do negative 8 times 3 over 2, I just have to multiply by the top, divide by the bottom. So negative 8 times 3 is negative 24. Negative 24 divided by 2 is a negative 12. Okay? All right, and then last but not least, let's solve this guy over here. It's going to go off to the corner. We'll add 2 on both sides. Cancel that. That leaves me with a negative 3m is equal to 2. And then I'll divide both sides by that negative 3m. So the last possible solution is a negative 2/3. Okay? And now these are the same. So I have I really have 3 different roots. So one solution is m equals 4. Another solution is m equals negative 12. And the last solution here is m equals a negative 2/3. Those are the 3 possibilities here. Or the 3 solutions that make this true. There it is. Okay. So that's how you use a zero product property. Let's see it in action. And this is a really important problem to have a conversation about because it's actually going to come up with something else is going to come up here that I want to discuss with you. So look at number 10. It says the front of a storage bunker can be modeled by this equation, right, where x and y are measured in inches. The x-axis represents the ground. So the x-axis is where the floor is for the ground. Find the width of the bunker at that floor level. So I basically want to know what is that distance from here to all the way to here. So what is this total distance across where the bunker enters the ground? How wide is that? Okay, so I'm trying to find this distance. Luckily, they laid, well, not luckily, I'm sure that was very deliberately, they laid the x-axis along the ground there. So if I could possibly just find what x value on the x-axis is that point right there, and what x value along the floor or along the x-axis is that point, then I could just, subtract them and get that distance. But if I knew what those x-intercepts were, okay? Now, this is kind of the cool thing. This is important. When I'm on the x-axis, and we've talked about this before, right? When I'm on the x-axis, I want to give you a big reminder that the y value on the x-axis is always at 0. So these solutions that we have been coming up with on all of these problems, right? And roots, zeros, when we graph, they are the x-intercepts. Because we're setting our equation equal to 0. Our output is 0. And on a graph, y is always 0 at the x-axis. So when we're finding these solutions, roots, zeros, say it one more time, we're essentially, all these numbers that we came up with and we said our solutions to all these equations, right? Guys, these are all where that graph intersects the x-axis. They are the x-intercepts. Okay, so keep that in mind. All right, so what we're going to do is we're going to use the zero product property to our advantage. We're going to use, and again, if I write it down, you'd write it down. So use the zero product property, okay, to solve for x. And the reason I can do that is because we're going to solve for x when y is equal to 0. That's why I can use the zero product property, because I'm going to be solving for x when y is 0. Because that's when we'll be on the ground, right? That basically is going to represent where the bunker meets the ground. There it is. Okay, so that's why. Right? It's at height 0, it's on the floor, okay? And so we can take that lovely equation that looks pretty nasty, but we're going to realize in a moment isn't too bad at all, and we're going to take it, and we're going to set it to a y equals 0, because then we'll be on the ground there, we'll be on the x-axis. Oh, that's not 75, it should be 72. Okay. There. Okay, so what we'll do is we'll say, okay, well, if you want to know how wide this is at the ground or what those x-intercepts are, those solutions, just set it equal to 0. So that's what we're going to do. Okay, now this is the other really important thing I want to emphasize for you. There are 3 things being multiplied here. We have that fraction, that negative 5 over 216. We have the x minus 72, and we have the x plus 72. Okay, technically, the zero product property would say that, if this times this is 0, then one of those has to be 0, right? Or that is true anytime any one of those is 0. Now, here's the deal. Let's talk about this fraction. If this fraction, guys, is just a number, a constant, and it has no variable, then it's not going to be part of my zero product property work, because there's no way that's going to be 0, right? In other words, if this is just a number, right? If I just had just a side note, right? If I had 3 times x equals 0, yes, the product property says if this times this equals 0, one of those has to be 0. But we already know this is 3. So we already know that's not going to be the 0. It would have to be this guy, right? So only factors that have a variable are the ones you need to worry about. If a factor, like in this example, negative 5 over 216, is just a constant, then you could set it up, and you're going to see how silly. It's like, oh, okay, well, let's try this one. That might mean this is 0, and then we'll be like, oh, wait, but no, but it's not 0. That doesn't work. It's just a number. So if it's just a number, and you know it doesn't equal 0, then you don't have to worry about it as far as your solution. That's not going to be a factor that will ever make this be 0. The ones that are going to possibly make this be 0 are the x minus 72, so I do have to set up that equation, and the x plus 72 equals 0. I have to set up that equation. So the ones that involve variables, those are the factors that you're interested in. If a factor is just a constant number, then it's not going to be the reason why it's 0. I mean, unless it's 0, but we don't have it. Right? So this one, I don't have to worry about it as far as solving. Okay? I only worry about factors that have x. All right. So if I solve this, I have 72 on both sides. Turns out that one of my solutions, and when we're talking about a graph, one of my x-intercepts is 72. The other one is at negative 72, so I'll subtract that. So these are my solutions or roots or zeros right here, which, coming back to our picture, means that my bunker is meeting the ground on this x-axis at negative 72 on the x-axis and at positive 72 on the x-axis. Now remember, what they wanted in here was, what is this distance across? So now we want to know, well, what's the distance from negative 72 to positive 72? Usually for distance, we subtract the new number by the previous, right? We kind of figure out what that whole thing is. Minus a negative becomes a positive. That makes sense. So when we add that, we get 144. That makes sense. Basically, we're saying we have 72 inches over here, plus another 72 inches over there. So we add them together. So the final answer here is the width of the bunker at the floor is 144 inches. Okay? This isn't inches right yet. Okay, yeah, so it's 144 inches, because that's the distance from negative 72 to positive 72, but because those are the x-intercepts, which are the solutions to the equation. All right, so that's 144. Let's try another one that's very similar. Let's try number 11. Try this, or maybe pause it, and at least try part A, and then we can come back and revisit. So it says you can model the arch of a fireplace using the equation y equals negative 1,9, x plus 18, x minus 18. And these are measured in inches. The x-axis represents the floor, so very similar problem. We want to find the width of the arch at floor level. So we want to know, from one end of the arch to the other, how far away or how long is that distance. That's what we want to know again, right? And again, the x-axis has been established on the floor. So if I could just know what this x-intercept is and what that x-intercept, wow, those are terrible arrows. Let's try that again. What that x-intercept is and what that x-intercept is, then I could, find that distance. Well, those x-intercepts happen to be the solutions when y is 0, since they're on the x-axis. So all I have to do is take our formula or our function here that models this arch and set it equal to 0, because at y equals 0, at a height of 0, we're on the ground, and that's where the x-axis is. All right, so I can find those x-intercepts. Cool. All right, and just like before, even though we're multiplying three things, this guy right here is never going to make the 0. Multiplying by a negative 1/9 will never result in a 0. It doesn't have a variable on it. There isn't even anything to solve for. So I don't have to worry about that if it's just a number when I'm using the zero product property. I'm only interested in factors that contain an x. So this guy could possibly make the 0 when it equals 0, and also this guy. And then we solve each one of these, right? So, the drill. We solve for x. So one of our solutions is negative 18, and the other one is positive 18. And those solutions happen to be the x-intercepts when we graph this. That tells me that the archway is touching the ground or meeting the ground at negative 18 and at positive 18 on this x-axis. And if I want the full distance all the way across, I've got 18 units over here and another 18 units over there. So if I find that difference, it's 18 plus 18, which is 36. So my solution for part A here is that the width of the arch on the floor, so the width of the arch at the ground, let's say, is 36 inches. Okay? Now this has a part B. So let's talk about that. This is a little bonus question. It says, well, how tall is the arch? Okay, so let's think about that on the picture. So now this is a different type of problem. It's saying, well, how tall is it? How tall is this up here, right? So we're basically looking for that y value, that really high up y value, and in particular, that y value, is happening where x is 0. So it's kind of the reverse here. We're not looking for that y-intercept, because that y-intercept on that picture looks like it's the highest point. That's how tall. That's how tall this archway is going to be, okay, if I walk right through the middle of it. So now I'm going to hit this in reverse. Now we're looking to say, hey, well, what would be the y value if x is 0? Because remember, when we're on the y-axis or at the y-intercept, it's always x is 0 there, right there in the middle. So we're basically going to take the exact same function that was modeling this archway, and this time I'm going to kind of hit this in reverse, and we're going to say, well, what if we're right in the middle where x is 0? Then what would be that y height? And that's what we're going to solve for when we answer that. Let's simplify that out. Well, in the parentheses, 0 plus 18 is just 18. And 0 minus 18 is just a negative 18. And then negative 1 9 times 18, that's really 18 times 1 is 18. 18 divided by 2 is 9. I mean, it's 2, sorry. So this right here is just a negative 2. I'm going to do that. And now that I know that's negative 2, I multiply by the other negative 18, and it turns out, it's a 36 also. That's coincidence. Not all of these arches are going to have the same width at the ground than their new height, but this one did. So the height, or the tall, the arch is 36 inches tall. 36 inches tall. That's the highest point there. Okay, and that will be the answer for the part B. So the moral of the story, most importantly, is that when we were solving these for 0, right, when we're setting that y right here equal to 0, that we're really looking at those x-intercepts. So the cool thing here is that the x-coordinates on the graph are the solutions, sometimes we call it that, the roots, you'll hear that a lot too. Sometimes we call them the zeros. But mainly the big thing is solve it for when y is 0. Set equal to 0 and then use that 0 product property. So we'll finish out with number 12 here. If it says find the x-coordinates of the points where it crosses the x-axis, then we know this is always going to cross the x-axis along the x-axis, which means y is 0. So we would just do what we did earlier, is take this factored polynomial, we would set it equal to 0, and we would use the 0 product property to say, okay, well, that means either this is 0 or this is 0, and then we would just solve each mini equation. So one solution would be at 11, or one x-intercept would be at 11, and the other one would be at -6. And does that look right? Yeah, right? This looks like this could be at x equals -6. This guy looks pretty good to be at 11. Okay? Let's try that again. This guy looks like it could be at 11. All right? And that would be where it intersects the x-axis if you're thinking of this in terms of a graph. And that's our solution. I mean, that's our notes there. Try 13 if you'd like, or any of the ones that we kind of skipped. You can then check your answers against the answer key on Schoology if you want that extra practice.